Welcome back. I'm recording now. All of your lectures have been updated on YouTube, so everything is there. Um, just to get started, I want to do a review of what we did yesterday, and then we'll do some new problems, and yeah, we'll see how we do for time. So for anybody who was here yesterday, I did this example. For anybody who wasn't here yesterday, when I say yesterday, I mean last class, this is a new one, or this is something you haven't seen before. So the way rate law works, let me just for a second here, ignore the rest of it. The way rate law works is the rate is always equal to a constant K times the concentration of the reactants raised to what's called an order. Oop. And the order is given to you. Square brackets, by the way, means concentration, which is, of course, as you know, from chemistry 1120, moles per liter. It looks kind of complicated. It's really not. Well, actually, I mean, this is very complicated chemistry, but in 1121, we kind of take it easy. If you guys ever go on to do, maybe university degree, or you go to do more kind of physical chemistry, they call it, you'll see a lot more of this. I always found it difficult. Okay. So let's look at this one. I want a pointer or a laser pointer. I don't know. I don't know what I'm doing. Somehow got a stupid pointer happening. Oh well, looks kind of cool. Anyways, so here it goes. I do not care. Oh, okay, I gotta figure it out. I do not care about the products. So my rate, and at this too, I remember Iman or some other students mentioned this the other day. The coefficients don't matter. I only care about the rate is equal to the rate constant K multiplied by the concentration of my reactants. So I have HBr and I have CaOH2. Excuse my bad writing. And then I raise these to the order that is given in the question. HBr is first order. Calcium hydroxide is also first order, which just means I put a 1 and a 1. For anybody who wasn't here yesterday, or Sunday, if this was second order, like if it said HBr was second, I would put a 2. If it said HBr was 0, I would put a 0. Your numbers will basically be 0, 1, or 2. Okay, so that's my rate law. That's part A. Part B, what is the overall reaction order? You add up the exponents. Okay, so I'm adding up one first order and another first order. So the overall is 2. The order, like if we had more time and we weren't, maybe I find teaching online is a little difficult. I'm sure you guys feel the same. It's really interesting concept of what the order means. But it's kind of up to you how deep you want to go into it. It's very mathematical, which is kind of not the point of this. But anyways, it's an interesting topic. Okay, so let me just check. I think I have 2 more. Oh, I don't have 2 more. Okay, pretend you didn't see that red part. Why don't you guys try this one? This is a really kind of weird one. Actually, I love this one. Just take a minute or two. I'll put myself on mute and just try this one. I obviously want the rate law. And then I want the overall. This one's so easy, it's tricky. Excuse me. So I'll be back in 1 minute. Okay, just another 30 seconds or so. Hopefully not rushing you, and we'll do the answer. But there is already a good answer in the chat, and if you have your notes printed, you already see the answer. So, but anyways, just take another 15 seconds now, and I'll put the answer up. This one's weird. Okay. Let's do this one. I love this one. This would be like, I don't know. It's cool. So okay, let me say two things. I personally, and I know most normal humans on Earth would accept two answers for this. So okay, let's read the question. In the reaction below, H2O2, so that's hydrogen peroxide, is a zero order. Oops, no, go away. A zero order reactant. You'll notice that there's no other reactants here. So I don't care about I mean, again, the rate is determined by how the reactions or reactants turn into the products. So rate is going to be, it's always K. K is a constant. It's like heat capacity. It's like pi, well, heat capacity is a better example because it's a constant you need in your equation that depends on the chemical. Okay, so I mean, that's really the answer, but why the heck is that the answer? Well, you could go a little further. You go H2O2. Again, guys, this 2 doesn't matter. I don't care about balancing. Now, here's the thing. This is to the power of 0. It's a zero order reactant. So this is fine. I mean, I love this. I would take this any day. But mathematically, when you raise something to the power of 0, it becomes 1. Like, I don't mean the exponent becomes 1. I mean that number becomes 1. So 50 to the power of 0 is 1. A million to the power of 0 is 1. So you could, and I think this is what was said in the chat, you could just say rate equals K, right? Whatever you want. I mean, on a calculator, this would give you the exact same answer. So this is good. Overall reaction, 0. That's it. Done. Halas. Pretty easy one, but this is a good question. Speaking of good questions, wink, 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 the next slide is a really good question. Okay, so I'm going to move on. If you guys have any questions, let me know. But this next slide, boop, is a good one. I'm sorry, I'm just reading. Okay, cool. Honestly, sorry, I'm just trying to give you the best hints I can here. Honestly, sometimes on a test, the way that this question works is part A. Oops, that says part, doesn't look like part, does it? Part A would be, find the rate equation. And then this would be kind of part B here. I'm not saying that for sure. I mean, I haven't written your test. I mean, your test is like a month away, but typically sometimes if this was a test question, wink, 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 part A, we would make you find this. I would obviously give you information. I would say it's, a first order reaction, blah, blah, blah. And then in part B, I would get you to actually calculate the rate. Okay. I'm going to give you one hint before I do this answer. The units for rate, and I'm giving you this hint because units can be a nightmare here. So really, I mean, look at these units. The units for rate are always mole per liter per second, okay? It's like kilometers per hour, but for chemistry. So instead of kilometers, it's concentration. And instead of hours, it's seconds, because, chemical reactions are so fast. So my rate is equal to K 5 times 10 to, so I shouldn't ignore my sig fig, should I? 5.0 times 10 to the negative 5 multiplied by my concentration, 0.75, and that's it. I have a calculator. Never mind. I was going to say I really don't like doing scientific notation on my phone. It really doesn't work very well. I don't know if it's just my Android or what I'm doing, but anyways. So I end up getting 3.75 times 10 to the negative 5 mole per liter per second. If you want to be fancy, you could just say 3.8 times 10 to the negative 5 mole per liter per second. I will be honest, a lot of you guys on your test were very bad with significant figures and units, but I didn't take off any marks. But just be careful in your labs, okay? Don't worry about it for tests, but just watch out on your labs for sig figs. They'll get you on your labs. All right, cool. Let me check the chat, and then I'm going to get you guys to do another practice problem for me. Sorry, if it's first order, mentioned. No, okay. So there's two things I'll mention here about the statements. Yeah, if it's first order, right, you don't need to put the 1 in there. It's like in math, 1x, you could just say x, right? So you don't need to put the 1, but you're more than welcome to. As a student, a million years ago, I just put the 1 in anyways, just to be safe, right? Just to kind of get my head wrapped around that it was first order. This is, by the way, a first order reaction. Okay. The other thing I'll mention is, so apparently, yeah, you guys this week are doing, some of you are doing your labs, or most of you, and you did the catalyst experiment. I'm glad you like that. It always amazes me how fast it goes. I think it's the experiment where it goes from like red to yellow, and it takes like it barely happens without the catalyst. And then when you put the catalyst in, it happens immediately, like within a second. Yeah, 2 seconds exactly. Okay, so how about you guys try one? I'm going to make you guys try a harder one. Oh, whoever put the answer on this slide, it wasn't me. I didn't make this slide. Shame on those people for not rounding it to 3.8. But anyways, okay, this is a good one. Wink face. This could be a multiple choice. I mean, it might look complicated, but you're really just plugging or putting numbers into an equation. Take a minute or two, try this one. Watch out for the 0. And again, this is very hard to do on a mobile phone unless you have a scientific calculator, but give it a try. And yeah, I'll be back in like a minute, maybe 2 minutes. All right, keep working. I'm just going to address a few questions here. First, the question is and this is where the units get confusing sometimes. This is a great question. So the unit for rate is moles per liter per second. Where did the second come from? The second comes from here. In your K. This means per second. So because it's like second to the power of -1, that means it's there. That's where the second comes from. Like, trust me, I'm not faking this. This is truly where it comes from. Just trust me that the units for rate will be mole per liter per second. The second question, and now I regret closing the chat screen, from Abdul Halim is, for CO, we don't take it in the calculation because the power is 0. Yes. So there's 2 ways to approach this. 1, you could just eliminate it. Or 2, you could put it into your calculator. Your calculator will eliminate it for you. Okay, so trust in your calculators. I know some of you guys might not trust your, well, I know that's not true. I mean, most of my students, I used to teach math for a while and everybody did everything on their calculators. But yeah, trust your calculator. But Abdul Halim, if you don't want to include it, you don't have to. But again, your calculator will do it for you. Okay, so let's do this one. I mean, this is pretty easy. Yeah, okay. I won't bother handwriting it because the information's all here. So rate is, here's my K. Let me get my highlighter here. So here's my K. Here's my concentration of NO2. Notice that it's raised to the power of 2. And then here's my concentration of CO, carbon monoxide, and it's to the power of 0. Your calculator will do this for you. But as Abdul Halim said, if you don't want to bother, if you know the math and you don't want to bother putting it in, you can ignore it. It's up to you. Again, I'm that weirdo who puts it in his calculator anyways. So here the rate is 0.34 mole per liter per second. Pretty easy, right? I mean, it gets crazy, or it has the potential to get crazy, but it's pretty straightforward calculation. All right, how you guys feeling? We still got a little bit of time left, so I am going to keep going on a little bit because, you know, we don't have class on Thursday. But yeah, if there's any questions, let me know. Oh yeah, Half-Life. I forgot about Half-Life. Sorry, hold on. Okay, well, let's at least finish this section. I mean, we might as well finish this section. It would be crazy not to. This won't take me very long, don't worry. The equation looks pretty crazy, but it is pretty straightforward. It does look insane, but it's not hard. Okay, so let me check the chat first before I get in too deep on this Half-Life stuff. Oh yeah, well, I agree, Abdul Halim. In physics too, I mean, you know, that stuff gets crazy. Anyways, I could talk about it forever, but my brother, who used to work here, he has his master's in physics, and you know, when I was in university, I did some physics, and I used to get him to help me, but the stuff he was doing was crazy. Anyways, won't talk about that, but yeah, I find a lot of the sciences and math courses, they get crazy potential to go a little insane. So remember chemistry 1120 unit 1 isotopes. You guys probably haven't talked about isotopes in a year, or at least since last September. Don't worry, we're not going to be talking about, you know, protons, neutrons, electrons, or anything like that, but half-life is something you would hear about, or you might see in carbon dating. Half-life is a rate law, or an equation based on rate. What happens is many isotopes are unstable. You know, think of like radioactive isotopes. You know, uranium is a good example. These guys are unstable. And what that means is they decay over time. So, you know, some chemicals are stable for millions of years, but you take a radioactive chemical that's unstable, well, over time it begins to decay and it breaks down. What's happening is it's splitting into 2 smaller atoms. Very interesting process, very much a physics process. So we're not getting into radioactive decay. We will be talking though about the half-life. The half-life of an element or an isotope is the time it takes for half of its mass to disappear. Well, disappear is a bad word because we know law of conservation of mass. It doesn't disappear. What happens is half of its mass kind of decays. It turns into something else, right? Think about if you had a fresh, you know, juicy apple and you left it on your counter for a month in the sun. It wouldn't look the same and it wouldn't weigh the same because it would have lost a lot of moisture to the air. You can think of isotopes and decay like that. It's losing bits of itself to the environment. So half-life is a rate situation, and it's the time it takes for half of the mass of an element or isotope to decay or break down. I shouldn't have said disappear. I feel bad about that because nothing disappears. Okay, so this formula is in your data book. This is a good multiple choice question. Winky face. Not this question, but you'll see the question on the next slide, but this formula. It looks pretty intense, but we're going to keep it simple in chemistry. I'm not going to get you to solve for anything crazy. Basically, all this is putting numbers into an equation. So what do all these letters mean? And again, this is in your data booklet. MT is the mass after some time. I don't know what the time is. It could be 100 days. It could be 1,000 years. But MT is the mass after the time T. MI is the initial mass of the chemical you have. The 1/2 is kind of like your constant. It's why it's called half-life. And then now this, guys, is an exponent. Be careful when you're entering this on your calculators. T is time passed over the half-life time. And this information will all be given to you. So T is the time passed in the question, and T 1/2, this is the time, this is like your rate. This is the time it takes for this chemical to lose half of its mass. This sounds complicated. It's pretty easy. Carbon-14. Famous element for carbon dating. This is how when they find like human remains, yeah, I guess that's the best example, human remains, they can estimate how old the human was based on how much carbon they have in their remains. I guess it would be their bones. I am not a biologist, but carbon dating is used to estimate how much time has passed since this creature has died. I guess the idea is when a person or a creature dies, their bones, everything stops working. So the calcium, the carbon, everything in your bones begins to decay. And if you know the half-life of carbon, and you can find out how much carbon is in the bones, you can calculate how old the thing is. Pretty cool. But we're not going to be doing that in chemistry. We're going to keep it simple. Carbon-14 has a half-life of 5,730 years. So, guys, what that means is every 5,730 years, the mass of carbon is now half. Okay, so if you had 100 grams after 5,730 years, you would have 50. After another 5,730 years, you would have 25, and it would keep going by half. So how much of a 14.2 gram sample will be left after 13,970 years? So first, let's write the formula. MT equals MI times 1/2 raised to the power of the time over, I'm sorry I'm writing small, I'm in too deep now and I have to keep going, but there's my formula. Okay, just put in your numbers. So, okay, what are my numbers? Well, this is my half-life time. This is my time that I'm looking for, and this is the mass of my initial sample. So all I have to do to calculate MT is say 14.2 grams multiplied by 1/2, and then it's 13970 over 5730, and that's it. I get my answer. All right, I keep forgetting I have a calculator here. I was dreading to do this on my phone. I strongly recommend, especially guys with this chapter, that you start to use your calculators a little bit more. You should all have calculators from math, engineering, chemistry, whatever. If you have lost your calculator, this would be a fantastic time to get one. Okay, let me just check yes, perfect. My calculator is perfect. So I end up getting 2.6 2 grams. Whew, halas, finished, easy. Wow, how does that seem? I'm getting some good answers in the chat. Oh, did I miss something? Okay. Oh, okay. Sorry, I'm reading the chat backwards, so I'm like completely confused about what's going on. No problems, Aisha. Not a problem. Oh man, this is some interesting chat. Half-life is probably related to stars. Again, physics. I didn't do anything about space and chemistry, but definitely stars and objects in the universe have a lifespan. So stars don't last forever, as scary as that sounds. I try not to think about it. But anyways, Abdulhalim, I would not recommend converting time into seconds. I mean, you can, but leave it. Just keep the time the same. What I mean is, if the question is giving you the time in hours, leave it. If the question is giving you time in years, convert it, or leave it. Just leave it. Don't mess with the time. And no worries, Aisha. And nope, sorry, Hadil. Sorry, this is a private message, but it's a good private message. Yeah, sorry, I just want to check something out. Hadil, your question's good. Yes, you will only be asked to calculate this. Now, you're lucky because if you had to calculate other numbers in this, you need some mathematical tricks like logarithms or natural logarithms. Don't worry, you're only going to be calculating MT. Whew. Okay, finale, guys. It's 4:08. We are almost done for the. No, sorry, you are almost done for the week. I have to work tomorrow and Thursday, but try this one. I'll just give you 2 minutes. Going back to, I think it was Abdulhalim's question. Because this is in hours, just leave it as hours. Don't change the time. The units for time will always cancel. So as long as the units are the same, it doesn't matter. All right, take 2 minutes and we'll finish this off. All right, I'll be back in 2 minutes. Sorry, one last thing. Try to do this yourself. I know the answers are on the slides, but try to do it yourself on your calculator to make sure you can do it on a test. All right, I'll be back in 2 minutes. All right, I'm getting lots of answers in here. And okay, so speaking of the answers, I'm getting like some different numbers, like 2.59, 2.6, 2.67. Don't worry too much about perfection, as in like if somebody said 2.59 and somebody said 2.62, it's not a big deal, but it kind of depends on how you're rounding and the way you're using your calculator. Just try to enter the numbers as they are. So okay, let me clear my ink. Radon has a half-life of 91.8 hours. If I have 25 grams sample, how much will be left after 300 hours? Okay, so let's make a list here. This is my half-life. This is my time. This is my mass initial. So my mass after that time would be 25.0 grams multiplied by 1/2 multiplied, or it's not multiplied, raised to the power of 300 hours divided by 91.8. And you would get your answer now. So this would, so this would technically be, if you did it on your calculator, you'd get big number. Proper rounding would mean we'd round up, so you would get 2.60 grams. Do not care what you put on a test, but as long as it's near 2.6, I am happy. All right, guys, that's it. Perfect. Abdullah, Iman, Aisha, great job, great job. Abdulhalim, yours is a little high, but maybe put in a number backwards or something. I've done that before. Cool. All right, halas, we're finished. You guys enjoy your, this is probably your last class, I guess. So enjoy your long weekend. Be safe out there, wash your hands. Thank you, Iman, and everybody else. If there's any questions, yeah, thank you.
Yes, sir, Master. Thank you.
Thank you so much. If there's any questions, let me know. Thanks, everybody. I will, Yasmin. Thank you. And thanks, thanks, Abdulhalim. Yes, there's a question.
How are you?
Good,
I want
good,
to
thank you.
discuss my test grade when I can come to the office hours, or when are you available?
My office hours are done online, and they're posted on D2L. Your test is outside my door. So what you can do is just next time you're on campus, pick it up. Or I'm on campus on Thursday, but I'm in meetings, so I can't meet. We have development. But yeah, if you can grab your test, or I can grab it on Thursday if you don't want to come to campus, and then we can meet on Zoom.
Okay, I will see, and I will let you know, or do an email or something.
Yeah, send me an email. You can check out my office hours if you want to meet some evening. If my office hours don't work, but you want to meet at like 6:30 or something, I can do that too. So just send me an email and we'll figure out a time.
Okay, thank you.
Cool, thanks. All right, bye-bye. All right, thanks everybody. See you later.